Okay, folks, today we're factoring by grouping, and the key to this is remembering to factor completely. Now, one of the things about factoring with grouping, when I would use it, when I notice four terms. I have a polynomial with four terms. First thing that comes to my head is factor by grouping. Here's a basic template for what we're doing. Just like in my past videos, I like to give an overview of what we're going to do. So you can get that down into your notes if you want to and see the big picture before we just start breaking it down. You do need to know different types of factoring out GCFs, and factoring the difference between two squares. And so if you don't have that information, you can go back to previous videos where I kind of break all of that down separately. So the first thing you're going to do is look to see if there's a GCF, and there isn't in these four terms. However, if we group the pairs of terms, group them into pairs, like this, notice I put the negative into the grouping because it helps me to factor out a negative if I need to. Now I can see that there are common factors in each binomial. So the next thing to do is to factor the GCF from each of these separately. So what is the GCF for 16x cubed plus 12x squared? Well, I have it right here. 4 goes into 16 and 12. And the greatest common factor for x to the third and x squared is x squared. It's always the least exponent. Now I factor those out. 16x cubed divided by 4x squared would be 4x, the remaining factor. You can always test yourself to be sure you're right by just distributing it and multiplying back. 4 times 4 is 16, x squared times x is x to the third is 2 plus the invisible 1 is 3. And then, of course, what do we multiply to get 12? 4 times 3 is 12, and x squared. So 4x squared times 3 is 12x squared. And let's do the second pair. The greatest common factor for 175 and 75 would be 25. This negative indicates to me to pull out a negative, so it's negative 25. When I do that, please notice that this sign here changes, which is important. So negative 25 goes into negative 100 4 times, with x remaining with it, 4x. And negative 25 goes into negative 75 3 times. Reverse that to check yourself. Negative 25 times 4 is 100, negative 100. Negative 25 times 3 is negative 75. Now, this is why it's important. Because if these two factors are not the same, you can't continue. You just can't continue with the process. So if they're not, check to make sure you took out the negatives correctly, or did you choose the right factors, or maybe you just have a polynomial where another method would be useful. All right, so we do have the same term here, which now is the greatest common factor. So the next thing we do is we factor out 4x plus 3. That's the greatest common factor now. And so I have 4x plus 3 times what? Well, these remaining factors. So I have a 4x squared there and a minus 25 there. I put those together and I end up with 4x squared minus 25. But I'm not done. I know, these are multi-step. So the difference between two squares is the next thing you must recognize. This is the difference between two squares. A square is a number that is formed when you multiply another number by itself. So 2 times 2 is 4, 5 times 5 is 25. Recognizing the perfect squares is important. I covered that in another video. Please go back and watch it if you don't remember what perfect squares are. So the template, there's a nice little template for that. You take the square root of the first term and write it 2 times. You take the square root of the second term, write that 2 times, and you always have a plus and a minus. I put minus and plus. Well, it doesn't matter what order you put them in. That's not important. So the final answer is here. carry down that 4x plus 3. He can't go away. And the other two expressions here, binomials, are 2x minus 5 and 2x plus 5. This is your final answer. That, folks, is the basic outline for what it is that we're going to be doing here. All right, so let's do a few examples. Step 1, I'm going to group. Pair them up. The next thing to do is to factor out the GCF from each pair. So in this case, I am factoring out the x squared, and I'm left with x plus 6. In this case, I have a negative here. I will factor out a negative number, and that is 14, and I'm left with x plus 6. Good thing, because remember what I said, you can't continue with this process if you don't have that. Factor out the greatest common factor. This is it. We're factoring the GCF again. So I get x plus 6 times what? Here they are, folks. Put those two together, and you have done it. I'm looking at this. This is a difference. This is a square, but remember, this is not a perfect square, so we cannot factor any further. All right, the next one. 3x cubed minus x squared minus 12x plus 4. All right, first step, go back and read it. Group the pairs. So grouping, parentheses, they're together. And now I'm factoring out the greatest common factor from each one. In this case, that would be x squared. The remaining factor is 3x minus 1. In this case, I have to factor out a negative. Remember I said that, so I'm going to factor out a negative number. But what is it? Well, 4. 4 goes into 12, and 4 goes into 4. And I am left with 3x minus 1. Check yourself. Negative 4 times 3 is negative 12. Negative 4 times negative 1 is positive 4. We know we've done it correctly. And we can see that these two do match up. GCF again. So I write 3x minus 1 and x squared minus 4. Now, am I done? No, Miss Malone, you're not done, because this is a perfect square. And it's the difference between them. So, again, let's use our handy-dandy template. We put two pairs of parentheses. Take the square root of each of those terms. So the square root of x squared is x, and I write it twice. The square root of 4 is 2, and I write that twice. And what do I put in the middle? A plus and a minus sign, except this time I'm doing minus and a plus, just to be different. All right, so that's 3x minus 1. Can't lose that fella. And we have completed that factoring. Another example. Okay, have you got that down? Let's do it together. Greatest common factor here, x squared. What's remaining? I pull out the x squared, I have 4x minus 5. Now, what is going to happen here? Sorry, I didn't pair them up. I'm doing it mentally, not on the paper. That's not good. All right, so what comes out of here would be plus 16. And 16 times 4x would be 64x, and 16 times 5 is negative 80, minus 5. And again, I'm looking to see, are those matching? Yes. So I can continue. I'm going to put these together. I got 4x minus 5 is the greatest common factor, and x squared plus 16 are now a couple, no, they're a pair, and of binomials. And there we go. We can't factor further. Remember, you cannot factor the sum, cannot. Factor the sum of two squares. Why do I make such a big deal about that? Because many of my students get tricked by that, and they do. All right, so you're not going to get tricked. That's the good news. All right, here's your you try. You do it, I do it, and we compare. So that's x cubed plus 4x squared plus 4x plus 16. And the second one, 4x cubed plus 7x squared plus 36x plus 63. There you go. So pause the video. You do, I do, and we compare our work. That's the way it works, folks. Pausing. I hope you are. And presto changeo, you're back. My final answers are there. This would be the answer to the first one. This is the answer to the second one. How'd you do? Well, I hope you did well. You all got 100. And give yourselves a pat on the back. You've done great. And I am going to see you all next time. It's been fun. Have a great day.